Welcome to solution vector unit. Let's get right start to it. Number 1 through 4. U, V, you just have to move this in delta mass, and then you will get here, which this point is -4, -3,7 component form. Therefore, we have to write our answer as -3,7. I'll only solve one question from each number so that you can have some practice too. Number 2, current vectors U, V. Find the sum of U plus V. 8 plus 8, 5 plus 7, therefore 16,12 component form. Number 3, find vector, given vector, find 2v. You just multiply 2 for each side, not each side but still, which gives you 8, come out from -4. And lastly, number 3, let the vector v have an initial point at 4,7, which is about here, and -2,6, which is here. You just drag your arrow over here and then move it on the origin. Then you get this equation at this point, which is -6, -1, which is our component form. Magnitude, we simply have to do -6 squared plus -1 squared, which is equal to -37. Therefore, root 37. How do we get the direction of the angle? Because this is, if you draw it as triangle, then this is 6, 1, 1. You find here. You have to find the arctangent of -6 over -1, therefore is tangent -1 over 6 over 1, which is equal to 9.46 if you try it. Nearest degree, so 9. But then, since we're on the third quadrant, you have to add 180 degrees to 9. Therefore, your direction of angle is 189. Welcome to our next video of vector unit worksheet number 5. Let's get right into it. So you were supposed to find the sum u plus v. Therefore, if you do this, just like the problem we did before, you put these two as 6 cosine 145, 6 sine 145. Now we do the same for these two, which we get 4 cosine 195, 4 sine 195. Okay, now, because you're supposed to add the vectors, you simply add them together. So then you get 6 cosine 145 plus 4 cosine 195, comma 6 sine 145 plus 4 sine 195. Now to find the magnitude and direction of these, you have to root, let's call this value x and this value y. So then we have to do root x squared plus y squared, which is our magnitude. In this case, if I calculated, I got 9.1. You can try to cross-check your answers later. And for the direction of angle, as we said, we can do tangent -1 and y over x, which I got in this question 154.7 degrees. That is our answer. Now, number 6. Given vectors of v equals -6, -2, find -0.5 graphically by stretching it. How we can solve this question is, first, because if you want to do -0.5, you write it as this, then you simply just multiply -0.5, which is, in this case, 3,1. So then you drag it over here like this, and then write the result in component form, which is this right here. Next question. Given the vectors a equals 3i plus 4j, b equals 5j minus 2j, compute the dot product a times b. A times b, how do you do this? Is first, this is the x, and y. So you simply just do 3 times 5 plus 4 times minus 2, which equals to 15 minus 8, it's 7. and that is our dot product. Simply just memorize this kind of problems. To find if two vectors are orthogonal, we have to find their dot product, and if their dot product equals 0, then they are orthogonal. So how we do this is just like the problem we did before. 5 times -9 plus 3 times 15, which is -45 plus 45 equals 0. Oh my god, dot product equals 0. Therefore, orthogonal. Number 9, a bird is flying at a true bearing of 75 degrees at a speed of 40 miles per hour. Write the velocity of the bird as a vector linear form rounded to the nearest hundredths place. Now, this problem may be very, 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 very difficult for some people. And then first, because it's a true bearing at 75, we do 90 degrees minus 75 degrees, just 15 degrees. So now if we multiply the components, we can go 40 times cosine 15, 40 times sine 15. And then if we calculate that, then we get 38.64 and 10.35. That is our velocity vector. And in linear form, we can write it as 38.64i plus 10.35j. That is our answer. Now, last question. 2 cranes are lifting a concrete block. One crane is pulling directly upwards with a force 800 newtons of force. Another crane is pulling with 650 newtons of force at a quadrant bearing of n 30 degrees east. Find the magnitude and direction angle of the resultant force. Now first, we have to see crane 1 is just simply pulling upwards, therefore x is 0 and y is 800. Crane 2 is very different because there's 650 newtons with n of east, so never east, so 30 degrees. How we can find the components of this is we do 650 times cosine of 30 degrees and 650 of cosine 30 degrees. Now, if we calculate these two, then we can get, what could we get? 563.9 and 325. Beautiful. Now, what we can do is we add these two for our total component. So then we get 563.9, 1125. Boom. Now, how we can find the magnitude first is, as we can see, if this is x and this is y, x squared plus y squared, which in this case is 58.5 newtons, and the direction angle is because tangent theta is 1125 divided by 5639, which we got from here. This is equal to 2, approximately. So then if we do tangent minus 1 of 2, then 63.43 degrees. Therefore, this is our magnitude and this is our direction angle of the resultant force, or how I explained it is the total component. Thank you for listening, and these are the section numbers in Delta Mass, so please review over them, and please let's have a successful retake. Bye.